excerpts representing different music genres. We just asked them to dance to the music. And based on the motion capture data, we extracted a bunch of kinematic features that describe numerically the certain qualities of the movement. Subsequently, our participants did the so-called Big Five personality inventory, which basically measures the personality traits of openness, conscientiousness, extroversion, agreeableness, and neuroticism. And for each participant, it gives a score along each of these 5 axes, personality dimensions. And then subsequently, we did some analysis on the kinematic features and the personality features to see if there are any regular patterns. And it turned out to be so. I will give you a couple of examples which are fairly obvious, I would say. The first one was with extraversion versus introversion. So extroversion can be described as a person being energetic, sociable, talkative, and outgoing. And here you can see 2 guys, and maybe you can guess which one of them is an extrovert. So this one is an introvert. Yeah, that was right. So what we found was that extroverts move more than introverts, not surprising, especially their heads, hands and feet. So that's was maybe the clearest finding. Another finding was about neuroticism. So neurotic people tend to be emotionally unstable, anxious, depressed, stressed. And we found a correlation between the neuroticism score and the way people moved. So neurotics move more on the spot and use less heads and hands than non-neurotics. So next time you go to a disco, then observe your dancing partner, and you might learn something about him or her. Okay. Gender and music-induced movements. So we're interested in gender differences in music-induced movement. Again, there are movement studies outside of the music field that indicate that gender can be recognized, for instance, from point like this place quite reliably. Gait kinematics can predict gender with very high accuracy. And interestingly, kinematic features predict women's perception of men's dancing ability, in particular variability and amplitude of movements of the neck and trunk and speed of movements of the right knee. So I just had to add this small piece of information here because I found it interesting. So we did this kind of machine learning experiment here where we trained a machine learning model to recognize whether a dancer is a man or a woman. And here are some specifics about it. So we had 24 participants from each gender, extracted a bunch of kinematic features from their dancing, and then used machine learning with these specifics, so some feature elimination and then linear discriminant function, so a fairly simple machine learning model. And so we came up with this magic formula here that tells about the gender. So hip wiggle, like lots of wiggle of the hips then predicts that it's a female and so on. Overall, the females moved more than the males, which seems to be a global phenomenon. And our machine learning model obtained 80% correct classification rate. And maybe it would be then interesting to see some of the cases, like if we take the person which is on the high end of the female scale. This is how it looks. You see the hip wiggle. And then the other end, the masculine dancing style, is this. Okay, and then if we look at misclassifications, like this is a female misclassified as a male, so. And then a male misclassified as a female. Okay, so I'm not sure about the usefulness of this study, but at least it shows that there seem to be some gender differences in music-induced movement. Okay, moving on to the last part, which is about emotions and music-induced movement. So this is actually related to what we did this morning. So music, as we know, it can convey emotions. It's very often conveys very strong emotions and has emotional impacts on humans. So we were interested in whether these emotions expressed by music are somehow embodied in the music-induced movement. And again, so we actually used the same data set. So music representing a wide range of musical genres, asked people to dance to it. Again, extracted some kinematic features that we thought were relevant from the motion capture data. Then we did a separate rating experiment, like we played the music pieces to participants and asked them to rate for each music how, the valence, arousal, happiness, sadness, tenderness, and anger of the music. And finally, then compared like with the statistical means the kinematics of the movement with the perceived emotions of the pieces to find correlations. And again, there were some correlations we found. I will again present you a couple of them. First one, if we take happy music, so what might be typical for dancing to happy music? Well, dancing to happy music was often associated with complex movement, a lot of rotation, so it was very typical for happy music. People tend to rotate around. Whereas with angry music, so it was associated with jerky movements, so which kind of reflect the acoustic characteristics of the music quite a lot. And then people did not rotate around with angry music. There were some other findings, but they can be found in the paper. Okay, so to conclude, so music has been found to induce movement, even in small kids. Music listening activates motor areas in the brain, both in the cortical areas, in the basal ganglia, and in the cerebellum. The hierarchical metrical structure of music is embodied in movement. So we kind of pass the metrical structure of music with our movements, so the different levels can be found there independently. Music-induced movement reflects personality trait and the emotional content of music. So I will stop here, and I would like to thank you for your attention.
Yes, sir. So I had two questions. So one was regarding the gender classification based on dance movements. Like if you had just 48 subjects test, like you had 48 test cases, and do you not think that considering the many features that you had, the model is susceptible to overfitting in a sense?
Yes, that might be the case. Let me think. But we used cross validation. Maybe it was not mentioned in the slides. So we used cross validation and feature selection in order to try to avoid the problem of overfitting. And so eventually we came up with like 5 features out of the large set of features. But this selection of features was based on like training the model with a subset of the data, then testing it with the remaining data and doing that many times.
Yeah, exactly. So 48 is a small number, right, for that.
Yeah, it's a small number. I agree. It's probably one thing is that collecting this kind of data is quite time consuming and so on. So yeah, this kind of data is probably not the best kind of data for machine learning approaches.
So the other question was regarding the study on emotion. So dance movement with the emotion that a music conveys, like one of the possible limitations, I'm not saying necessarily so, but one of the possible limitations would be that whatever the music conveys in a sense is also captured by its genre, and any genre of music has a cultural, like metal has headbanging, or a kind of music has a particular kind of movement associated. You brought that up initially, but so did you have any way of checking for that in the final experiment that you talked about?
Okay, so you are suggesting that there were like confounding factors, like
yes.
Yeah, that's totally true, and we didn't really check that, but that's a problem. I think next question would be from here. That's in general a problem with this kind of naturalistic approach. Is if we use real music, so we can't really control everything. And so there's like emotional content and genre might correlate, and I guess to disentangle them from each other, then one would need a huge amount of data, like a very large selection of music, and then doing this kind of experiments would take a long time, and you know.
Because that is how they see in television or on the internet.
True.
Via media, that affects. Talking about that effect,
Sure. Yes. I understand. But your question was related to the emotion study, anyway. Yes. So your point is whether these cultural effects would be like more stronger than the the emotional effects. Yeah, that's a good question, and I think we should really do more research on that. It's as I said, it's complicated because there are so many aspects affecting. Because we are talking about a fairly complex phenomenon here, and it has like the physical and personal and cultural aspect affecting it. Please.
Yes, thank you. When you look at this 60 dancers or 60 subjects, I understand that you look at them individually as one single. But what I'm interested, suppose you look at them collectively, as 60 people dancing together, then there should be correlation between the X and Y and Z. I mean, the first dancer, second dancer, third dancers.
Yeah.
And why it's important, because if you go back to the folk traditions, especially the tribals, where there is no individual dancer, essentially 100 people dancing together, and they're all, and the question is that the collective behavior which we have in physics, like and kind of synchronizations. So whether you look at this aspect.
That's a very, very important question, and I agree that, I mean, dancing is a collective phenomenon, and one should go into the collective dynamics of a dancing group. And we are moving to that direction. I didn't talk about that, but we have we have to proceed in small steps. So now we are starting dyads, 2 people dancing together, and then eventually going towards larger groups. And there have been some studies on, for instance, electronic dance music carried out in Norway on larger groups. I think like groups of 10 people dancing together, and how their collective dynamics develop and so on. It's a very interesting and also challenging question, because then you get not only this complexities of individual movement on the individual level, but then you also have the interactions, and if there are many dancers, then it gets very complicated. But of course it's challenging, and it's very interesting and relevant, so we should go more into that, and we will.
My recommendation is that you should go to the ethnic groups for collective behavior.
Oh yeah, that would be great. Then we just have to take our motion capture equipment and transfer. It's possible to do that as well, but of course here as well the kind of the cross-cultural aspect is relevant, and it should be done.
Regarding the small children who were exposed to a certain rhythmic bounce, my question is, before they were subjected to pay attention to the speaker, which rhythm they liked. Now I would like to know to what duration was that bounce exposure given to the child, before which you again subjected them to the same rhythm music or a different one to establish how much their attention span was.
I'm afraid I don't remember the specifics. I mean, they are in the paper. I'd be happy to send you a reference to the paper to check the details, but I would assume it's probably a few minutes that they were bounced.
So it need not be that it's a permanent memory that the child is going to get into. Is it going to be there permanently, or is just an effect after? Immediate effect.
Yeah,
That's what I would like to know.
I would say it's an immediate effect, and then it fades away. So it's kind of some kind of short-term memory.
Right. Thank
effect.
you.
There's one. Okay. Okay. I don't know. Okay.
I have a couple of comments, actually a question and comment. I was wondering what would happen if you feed the machine learning algorithm with human data, in the sense that you make few people recognize their own movements or genders based on the dance movements, and then you feed that data to the machine learning algorithm.
Sorry, human data, like
No, humans recognizing genders, and then you feed that data, the accuracy, the results coming from this recognition.
You would basically compare human
With the
classification with the machine
Yeah,
classification.
and then you probably feed the machine learning algorithm with this data.
Okay, I haven't thought about that, but that's an interesting idea. Actually, we didn't check how accurately humans could recognize. Maybe they can't do any better than the machine.
Yeah, related to that, there is this biomachine walker, BML walker, I guess, from the biomachine lab,
Yeah.
a mechanics lab. So
I
they
know.
use these point light walkers and then ask people to walk, and I mean it's an old study. And then people recognize their own movements. First they recognize genders, and then they recognize their own movements.
Yeah, that's right.
So we did a similar study with eye tracking and a few years ago, and we found that there's a huge gender difference. So males are better in recognizing their own eye movements than females. And then we found that there are probably evolutionary reasons behind it.
Okay.
I'm wondering how it could be, I mean, if at all it could be done in music and dance related movements. And I don't know, there could be, I mean, I would predict that females would probably do better at recognizing their own movements dance movements than males would, but it would be something interesting to ponder upon.
That's an interesting idea. Thank you.
So I have something to say. I will just continue with what Sir just mentioned about movement, where there's a group. I would suggest that those who are doing this research along with you can see a movie called Folly. F-O-L-I. It's a tribal group in Africa.
Okay.
And it's beautiful. It's like a 10 minutes movie. It's on YouTube. It's a documentary on them. And whatever movement they do, even if they're walking, it includes small children to the older people of whatever age, they move in rhythm.
Okay.
The women who are even making their huts make huts in rhythm.
Rhythm.
And that's how their daily life is. Nobody learns music, nobody is induced with any kind of, it comes naturally to them.
Yes.
So it's a very beautiful work that they have done as Folly, F-O-L-I.
Thank you.
So, I mean, those who are interested can just see that movie.
Okay.
Yeah.
Thank you very much.
I have a little question here in front.
Okay.
I was wondering whether you could comment on how some of this research that you've done can be applied in, I don't know, some context in society. For instance, just off the top of my head, the ability to distinguish between neuroticism and non-neuroticism might be some form of non-invasive diagnosis. Not that you'd have to ask people to dance before diagnosing them with some kind of... but I'm sure you might have more sensible thoughts on that.
Well, I would say, at least on a more general level, understanding about the relationship between music and movement probably has applications in music therapy. Like, for instance, say brain stroke patients and Parkinson's patients who typically have motor disabilities, and it has been found that certain kinds of music therapy can be beneficial for their recovery. And I mean, this is a very general answer, but maybe understanding more about this relationship between music and movement, how we embody musical media, and so on, might help them to develop better methods in the field of music therapy.
Perhaps as an indicator of progress, or in rehabilitation, maybe.
Rehabilitation.
Yeah,
Yes.
yeah.
Yes.
Okay. Yeah. Thank you.
Yeah, thanks. So maybe, you can, this is another way, maybe dance can be used to, like, actually what you had suggested was quite sensible. I don't know how feasible it is,
Yeah.
But yeah, why not? I mean, if you can use music listening habits to understand, like if you take that approach that you are what you listen to, or you are how you listen to, so you are the way you move, right? So yeah, I mean, why not?
Yeah, because there are very typical physical movement traits that are associated with personalities. That was also reflected in your dance.
Right.
Yeah, that's
Yeah.
one context. Thank you.
Yeah, I'd just like to add that I'm a musician myself, and what I have used music in certain cases is not just to induce movement, but as a confidence-building mechanism
No, yeah.
for people who are shy, who hesitated doing certain things. Working out in a gym, for example, where music actually helps them to propel themselves forward, where in the silent non-musical environment they wouldn't be able to do so, where they get that energy surge, that charge, that confidence that maybe I can accomplish this. And that is one of the reasons that many athletes use music as a booster.
Yeah, that's an excellent point. Thank you.
Actually, one small comment to the first question which that gentleman had asked, that you have the cultural, preconceived cultural movements in your head before you actually go for a model, right? So, like, assuming Latino, you'll have rotations and you'll have head banging with metal. So, I mean, I'm just thinking, how would it be if you can find the right subject? So, when you say find the right subject, basically, the ones who are not exposed to the kind of music that they are going to listen, and then they move to it. Maybe it can tend to be more accurate or more unbiased there, like some Maori tribal exposed to Bhangra music or something of that sort. Then I think there is a possibility of that cultural bias to go away. Just a thought.
Yeah, probably that would be so. So it would be kind of at least reducing that. Then basically one could assume that the
Then
movement
the equation
would
might
reflect the
change as well.
musical.
I mean, just off the top of my head, the equation of hip swings, and you had the feature vectors come out of it, right?
Yes.
So maybe that feature vectors, the kind of features you induce, the coefficients of those features might change a little bit. I don't know.
They might change, and yeah, maybe in that case, then if we would find like people ignorant to that certain musical style, then maybe their movements would then better reflect the musical content. Yes.
There's one more thing that I'll like to add to the thing that he said right now. Like